In this video, at first we had tried to send LoRa signal using normal rubber ducky antennas, but the signal was unable to cover long distance. Then we had attached this DIY UHF band dipole antenna and we got a stable connectivity far than 1.5 km without any line of sight. Making and tuning of this antenna, outdoor testing and all other details in the video, so stay tuned. So for this video, at first I will show you the outdoor testing and performance of this antenna. Then I will show you the process how to make this antenna. So let's start the video. So today I am going to compare this antenna with this standard rubber ducky antenna. For this experiment, today Soikot is with me and he will change this rubber ducky antenna with this standard dipole antenna, and I will show you the changes in the peak of the signal from around 1 kilometer distance. I will go this side in the jungle, so I am actually risking my life with tigers and lions and this kind of and seriously speaking, it's time to monsoon and snakes are a big problem, so please do subscribe my channel, it's my humble request. So here my RTL HDR is connected with my laptop and I am running HDR sub right now, and this side around 1 kilometer away my antenna is, and now I am going to start the transmitter there using the rubber ducky antenna at first. Then we will check if we are getting any kind of signal received here or not. Then we will change the antenna with the dipole antenna and we will again see if we get any data packet or not. So this is the plan right now. So let's say to Soikop to turn on the transmitter. CQ, this is Victor uniform number 3 Hotel Alpha X-ray conducting experiment on SX 1270 LoRa module.
Requesting Soikop to turn on the transmitter. Over.
So we had already turned on our transmitter, but as you can see here no any data packet are coming. So now we have to change our antenna from that stock rubber ducky into our handmade dipole. So I will request Soikot to change the antenna and let's see what happens. No incoming data packet has been received. Requesting
Soikop to change the rubber ducky antenna into handmade dipole antenna. Over.
So we had already requested Soikop to change the antenna and turn on it, and yes, our data packet are already arrived. As you know, first time we were transmitting using this kind of standard rubber ducky antenna, but that time no data packet was available, but this time here the data packet is clearly available. So our antenna is successful. All fellow engineers and electronics enthusiasts, welcome back to a new video of AkashWave RF. As you can see, right now I am in my hometown again, and you can never see this kind of greeneries or scenic beauty at Kolkata. So this time I am in a new project. I am going to make an antenna mast on my rooftop here, as you can see, for my all kind of multiple antennas. Basically it will be a fixed mast made with PVC pipe, water pipeline, and on this mast I will mount 4 or 5 different types of antennas, like a VHF band ham radio antenna dipole, basically an UHF band Yagi or dipole antenna for both UHF band ham radio and LoRa modules and 433 MHz other modules. Also there will be a QFH antenna specifically for weather satellite purposes like NOAA satellite or meteor satellite, because as you know, weather satellite signal are circularly polarized. We cannot capture those signals very high quality using a dipole antenna. For that we need helical antenna or QFH antenna. And also I will make some inverted V dipole antennas for 6 meter or other lower HF band ham radio purposes. So in this video I will show you how to make the antenna mast, and also I will make the 433 MHz dipole antenna also for my LoRa module. In our next video I will explain how to use the LoRa modules with microcontrollers like Pico or Arduino, and I will also give you the codes. But for this project I will only show you the making of the antenna mast, the making of the antenna, and I will also show you some part of antenna tuning using the NanoVNA. Although this NanoVNA or making antenna are a vast thing, so I will cover those things on a later video, but this video will be a general video on this topic. So follow this video for some knowledge, and I will make separate videos in depth videos on this each and every topic. So that's it for introduction. Let's make the antenna mast. So these are the PVC pipes today I bought to make the antenna mast for my antenna setup, and this one is a 5 foot long piece of PVC pipe, and I will use it for the main mast. And this is another pipe I had marked somewhere in this, and from this marking to the lower part it is around 3 feet, and I will attach this on the top of the 5-foot one, so that our UHF band dipole stays 8 foot over the ground. And also I had marked some places on the pipe on the top of here. This part will create the support of the dipole antennas element wires. So let's cut them and make the antenna setup. So for now our antenna mast is fully ready. It's huge, around 8 feet long, and on the top of it here will be our dipole antenna. Actually I am going to make dipole antenna using 6 thick electrical wire, and as you know electrical wire cannot be straight by themselves. In these parts I will tape the electrical wire so that elements were proper aligned, and here I will make 2 holes using drill, and I will screw them to connect the coaxial cable with the elements of the antenna. And in this part I can wrap my RG58 cable 5 to 6 times to make a 1-to-1 choke to eliminate any kind of external interference. So that's the plan for now. And also I had added a end cap here so that it's time to monsoon. So this is our antenna mast. Middle of this T here I will make 2 holes and attach these 2 wires with 2 screws, and one wire will go downward from here and another will go upward from here, like this. And I will also apply tape here and here to make these wires stable and straight. So this is the planning for now. Let's make the antenna. Now let me explain you how to make the dipole antenna. I mean the length of the dipole antenna, which is the one and only important thing. We are going to make a 435 megahertz dipole antenna, because all LoRa modules can operate on 435 megahertz, and also it comes under UHF band ham radio, so that I can also transmit FM band voice or LoRa signals, everything using this single antenna. So this is our dipole antenna. As you can see there are 2 poles. This is the top portion and this is the bottom portion here. The top portion is connected with the middle wire of the coaxial cable, and the bottom portion is connected with the jacket or grounding of the coaxial cable. So this is the connection. Total length of this dipole antenna will be 32.77 centimeter, which is from here to here, and each element's length will be 16.39 centimeter, which will be from here to here. Actually this is the calculative value, but in real life SWR can vary depend on the material or various other natural or other conditions. That's why we will take this each elements up to 17 to 18 centimeter each, and then we will tune the antenna by cutting the top and bottom portion by 2 or 3 millimeters each and every time, and we will measure the resonance frequency and SWR of this antenna. In this way we will tune the antenna. So this was the full planning of the antenna. Now let's make it. One more thing I have to warn about you. I am a licensed ham radio operator. That's why I can transmit up to 10 watt on this 435 or 434 to 438, any of these frequencies. But as a normal people who don't have any kind of ham radio license or other permissions, you should not transmit on these frequencies. For you have to strictly maintain 433 megahertz, which is a worldwide ISM band, or you can follow any other ISM band, like there are 800 megahertz something and 900 megahertz. These are also maybe ISM bands. So if you want to do any kind of experiment with LoRa's and this kind of modules, you have to strictly maintain ISM band, and for 433 megahertz your maximum power transmission should be quarter watt. So please keep this thing in mind and follow this. So for now, to make the dipole antenna, I am going to use 2.5 millimeter thick or 6 millimeter thick normal electrical wire, which is insulated, normally used in home wiring purposes. Later I will make the dipole antenna using proper aluminum rod or copper tubing, which are used in AC and these purposes, cooling purposes. You can ask me why I am using electrical wire to make the dipole antenna for this time, because now I will not transmit any kind of voice or high power using the dipole antenna. I will only transmit some LoRa signals, and LoRa signals are very low power, like 17 dBi or 30 dBi, which will be more than enough using 2.5 millimeter thick wire. And another main advantage of using wire is where you want to tune the antenna, you can easily cut the end of the wire using any kind of plus or any kind of cutter. And actually this way we tune an antenna by cutting its end parts. If you use any kind of aluminum rod or copper tube, filing them to tune in a proper frequency is very hard. So I thought that at first let's make the antenna using the wire, and after getting the proper measurement, then I will make the antenna using a proper aluminum rod or copper tube. So that's the plan for now. Now see how it works. So these are the two elements I had made for the element of the dipole antenna. Actually I had used here 2.5 millimeter thick wire, because 2 millimeter wire was too thick to cut and solder, and for this LoRa purposes and low power purposes 2.5 millimeter thick wire is also good. And as you can see on the top side, I had made two loops to attach this under the screw, and the bottom side is also tinned so that I can easily cut this side to tune the antenna. So this is the full setup. As you can see, here are the main screws, and there are two washers on the top and the bottom, and on these washers I will attach the coaxial cable. As you can see here, these places are already soldered, and I will tight the screw here, and these elements will be straight. Also I will apply some tape, so in this way it will be a good quality, steady and stable dipole antenna. Now our antenna is almost ready. Now we have to ready our NanoVNA and calibrate it to measure the antenna's resonance frequency and to tune the antenna. So finally here I set it up the antenna. As you can see, these are the two dipoles. Still I had not applied the tape on the top and bottom of the antenna module, but I think they are stiff enough. And this is our cable. This portion is connected with a SMA female connector, using which we will calibrate our NanoVNA for this cable. And here I had made a 6 turn, which is actually a 1:1 balloon or choke to reduce signal noise induced by the long wire. Actually this is a 9 feet long wire, which is a very long wire, and this wire will catch a lots of signal noises. That's why I had made this air core choke. You can also use a ferrite core if you have ferrite core or that much money. Sorry, I'm a poor guy. And this antenna should work perfectly fine. So now let's calibrate our NanoVNA with the choke and the connector here, and then I will attach the wire from here to here with the dipole antennas starting. So here I had already setted my dipole antenna on the mast. For now the mast is only 5 foot long. After properly tuning, I will attach this 3 foot long part also on top of this. As you can see, these all parts are modular. I can attach or detach any part anytime. So this is our 2.5 millimeter thick wire made dipole antenna, and as you can see I had also made a 5 turn or 6 turn air core choke here, and the RG58 cable is directly connected with the NanoVNA here. And as you can see, without any tuning, its resonance frequency is currently 479 megahertz. So it's higher than 435 megahertz what we exactly want to achieve. And I have to tune this antenna. It is a long process and I cannot show you the whole process, so I will show you after properly tuning the antenna. So it's around 1 PM at night. As you can see, the whole area is covered in darkness, and I just finished to tune the antenna, because in this summer afternoon time in Bakura it's like hell, literally 47-48 degrees centigrade. You cannot do any kind of work. So this is my total antenna mast, and here is my dipole antenna. As you can see, I had made using the 2.5 millimeter thick red electrical wire, and here is our NanoVNA. Let's check the performance of our antenna. So this antenna is properly tuned in 435 megahertz, and its SWR is 1.09, which is too good. And the impedance of the antenna is 53.5 ohm, more or less, and the reflected power is minus 27.3539. so it's also too good. So I'm fully satisfied with this antenna, and this antenna's performance is better than many commercial antennas also. So tomorrow during the daytime I will show you the antenna in details, and I will talk you how I tune it and other things. So for now, good night. So my antenna is ready to deploy, and as you can see, let me tell you for the last time what changes I had done here. At first, here I had made a 6-turn air core choke, but I had removed it because maybe due to low quality RG58 cable, that choke was also resonating on 470 megahertz. That's why I was forced to remove the choke. So I have to improve the quality of the cable, and total height of the antenna is around 8 feet from the rooftop. Now let me show you the antenna performance from the NanoVNA. As you can see here, our antenna is properly tuned in 435 megahertz, and in 435 megahertz we are getting a SWR of 1.091, which is very good. You cannot get this kind of SWR in commercial antennas also. And the impedance of the antenna is 53.6356 ohm, which is exactly what we need for this kind of RG58 cable or any kind of transmitter which impedance is 50 ohms also. And the reflected power is minus 27.19. During night time this also goes up to 29, so it fluctuates depending on the weather and other things also. So from the RTL SDR we can see our antenna became too good. So now here we have two sets of LoRa modules setted with all microcontrollers and other peripherals like display or other things, and I had also this course. By the way, if you want to watch a full details video on range testing of this E32 LoRa modules with circuit diagram and proper code, I had made a video on this topic. There I had also given you the circuit diagram and Arduino code also. You can check out this. I will give the videos link in the description box. So now we will upload the previous code which we had tested in our last video for range test. I will upload the same code, same transmitter and receiver code in both. Now I am uploading the same transmitter and receiver code on both modules to test my new antenna. As you can see, my LoRa module is already programmed and it has also started transmitting data packets. Now upload the code on the receiver. Again select Arduino Nano and upload the code here. If you want to download these Arduino codes and the schematic diagram also, check out my previous video. And here is our LCD display. Code is almost uploaded, and you can see here the display is already live and we are receiving the signal from this LoRa module. We will test our antenna setup with digital FSK transmission, LoRa transmission and analog FM modulation also. So stay tuned with the video and check it out how it works. Now we have to test our antenna with real life condition. For now I am going to test it with these LoRa modules. I hope you can remember these LoRa modules from my previous video. I had tested these modules range extensively in urban condition, and I got around 3.1 kilometer of stable connectivity without line of sight with these rubber ducky antennas. Actually this rubber ducky antenna was as a receiver, and for transmitter I was using a monopole antenna I bought from robo.in. And I also tested that monopole antenna with the NanoVNA, but it was too bad. It was resonating at 360 megahertz, and for LoRa module we need 433 or 435, and my this antenna is properly tuned for 435. So now this is our receiver. Right now here is the red LED blinking. It means no connectivity is available because the transmitter is already power cut. So I will remove the rubber ducky antenna from the transmitter module, and I will attach the LoRa module's SMA connector to the antenna's SMA connector, which is here, and then we will test it performance. Also, if you guys are interested to watch the previous range testing video of this E32 LoRa modules with that monopole antenna, you can check this video on my YouTube channel, or I will attach this video's link on the description box, so please check it out. Here I had connected my LoRa transmitter with the antenna, and this transmitter is powered up by this 12 volt adapter. If I turn on power here, as you can see, this receiver's LED turns green, and on the display you can also see the receipt number. Actually, this transmitter is sending a counting number in each and every second with its input voltage report, and on the receiver, on the display, you can see the counting is running 17, 18, 19, 20, and under this is the incoming battery voltage reading which it is getting from the transmitter module. It's currently 11.74 volt. It means this transmitter module's input voltage, which is currently it is getting from the adapter, is 11.74 volt. So this is the whole setup. As always, I had connected the RTL HDR with my laptop, and it's running RTL HDR software, HDR Sharp. And as you can see here, in proper 435 MHz, it's sending the LoRa signal in each and every second. You can also listen it, but it's digital signal, that's why it's just a noise. Also, you can receive the signal using this kind of handheld radio. If I power it up, you can listen that the data packet is coming exactly the same time. You can sync the walkie-talkie and the display also. Now I am going to replace this E32 LoRa with normal SX 1278 LoRa. So I will cut off the power of this E32 and I will disconnect the antenna from the E32. Then same type of SMA female connector here also. Inside this there is a SX 1278 LoRa module and a Pico. Now we will test SX 1278 LoRa modules transmission with this, because these E32 LoRa modules are too high power. We cannot really measure the output power and proper performance of this antenna using this kind of very high power modules. So that's why I am using this low power SX 1278. Plug in the battery. This whole thing run on a single cell lithium battery and turn it on, and this green LED is blinking. It means it's sending a counter in each and every second. And the main advantage of this SX 1278 module is it will also provide me the RSSI value and the SNR value, using which I can originally know how much power is transmitted using this antenna to the receiver antenna. So let's check it out. So recently I am around 750 meter to 1 kilometer away from my transmitter antenna, and as you can see here, we are getting minus 98 dBm of RSSI and SNR is 9.25 dB with this stock rubber ducky antenna also. It means our transmitter antenna is working perfectly fine and better than most of other commercial antennas, because these SX 1278 LoRa modules are very low power, just 50 milliwatt, and with 50 milliwatt without any line of sight, this distance is not that much easy to achieve. So it's working perfectly fine. So this was my complete video on how to make this 435 MHz UHF band antenna, and I had also successfully tested this antenna's performance with the SX 1278 LoRa module, and in future I will use this antenna for other LoRa experiments and FM voice transmission also using this kind of walkie-talkies. So this is for the video. If you have any kind of queries, question and other any suggestion, you can comment me down in this video, or you can follow me on Instagram and message me. My Instagram handle is on the description box. So that's it for today. Hi, I am AkashWave, call sign Victor Uniform number 3, Hotel Alpha X-ray. I am an electronics and communication engineering student. Actually I am passed out, and also a licensed ham radio operator also, and I used to make videos on microcontrollers, microprocessors, ham radio, radio stuffs, radio modules, RC plane, drone, RC hobby and this kind of stuffs. So if you are interested, you can follow me, do subscribe my channel and follow me on Instagram. So that's it for today. See you on another video of AkashWave RF, and bye. Hi, hello, do you want to be my assistant in this experiment? Hello, I will pay you, please. Okay, you have plenty of payments, I know that.